Good morning. Welcome back. So, last class we finished with the push operation, wherein push is nothing but inserting an element into a stack. Fine. And then stack is a linear data structure wherein insertion and deletion happens from one end, that is the top end, and then it follows the last in first out principle. We finished the algorithm, the procedure as well as the program. Now we'll move on to the pop operation. So what is pop? Pop is nothing but deleting one element or item from the stack is represented or called as an operation called pop. Pop is nothing but deleting an element from the stack. Okay. So when the elements are continuously deleted, the top shrinks. What do you mean by that? It shrinks in the top end means suppose I have 5 elements and my stack is full. So it is full. When I delete one, it reduces by one element. So top will go down by one element. Like that only, if I go on reducing, the every element popped out, the top will go down by one element. So then once you delete all or pop out all the elements, it will become empty. You can see here pop operations. There are three elements here and top is pointing to the last element, that is it would be the last element pushed in and it would be the first element which has to be popped out, that is last in element was C and this would be the first out element. That is what it means. And then I have popped out C. So once C goes out, the next element in the list which will go out is B. So top would be pointing to B. Once B is popped out, it goes to A. There is only one element. You can see the size is shrinking, right? It is going down. And then once you push in, it expands. It goes on increasing. Once you, like, normally you don't do push separately and pop separately. Push and pop are there together. Once you push in, you pop out, push in, pop out. It depends on that, like once, but if you try to push in more than the limit, it will give you an overflow condition, and if you try to pop out in an empty stack, it gives you a underflow condition. So it has gone down to A here, and then once A goes out, it is an empty stack and top becomes -1, because in an empty stack we saw during push also the top becomes -1. Clear? Please go through this again. Pop is nothing but deleting an element from a stack from the top. That is, it follows the last in first out principle. The insertion and deletion happens from one end, that is the top end of the stack. So as and when you go on deleting or removing an element, it shrinks in size. When you push elements, it expands in size. So push is for inserting, pop is for deleting. In push, you have to check for the overflow condition. That is, if you are trying to insert an element in already full stack, then it will give you an overflow. Same way, if you are trying to delete, like for example, here I have an empty stack. If I'm trying to pop out an element, there are no elements here, and what will it pop out when there are no elements? So it gives you an underflow condition, that is stack empty, underflow. So whenever you're writing algorithm for pop, you have to check for underflow condition first, and when the condition is not true, that is the elements are there in the stack, then only you proceed with the pop operation. The same way for push, you have to check for overflow condition. If it is not true, that is if there is still space in your stack, you can push in an element. So push and pop. Push is overflow, pop you have to check for underflow condition. How do you check it? If top is -1, then there are no elements in the stack and it is underflow. Getting it? Please go through this. Let's see. Every time your stack need not be full, it can have, like, any number of elements, provided it is maximum elements I can have is n elements. Suppose if the number of elements in stack is n, then maximum I can have is n, and I can have 0 or any number of elements. The maximum is n. I cannot exceed n elements. That's all it means. Here I have as and when you go on popping out, it shrinks, and as and when you go on pushing, it expands in size. When I say expands, it does not mean that it will exceed the end limit. Getting it? So now I will just show you the pop operation. Once you're familiar with that, we can start with our algorithm. So once you understand that, you will be able to relate or connect to the algorithm easily. Push and pop are repeatedly asked questions. Then 90% of the time they ask you the algorithms only, which are very simple and which would fetch you 5 marks. So please don't leave these questions. Either they ask you stacks or queues in your exam. It's a 100% question. One question is definitely asked. Either it will be from the queue or from the stack. So see, I have already pushed in the elements here. Number of elements is what? 5, right? Because I can see 5 elements here. 0 to 4 is 5 elements. I have declared int s of 5. So 0 to 4, and then I have pushed in all the elements. So the stack is full at present. Like I have 120, 100, 99, 78 and 34 stored in 4, 3, 2, 1 and 0 locations. So 0 to 4 is 5. So top would be pointing to the last in element, which would be the first out element, correct? So top is pointing to 120. Now I have to pop out the elements. Like if I have to delete 78, then I need to delete 120, 100 and 99. So let me start the procedure here. The top is 4, yes. Why is it 4? Because it is, whenever I say 4, I would be taking the index value of it. This is an array based representation, so you will have index values. Top is pointing to the location 4 because 0 to 4. So it would be the fifth element. The value of top is 4. Whenever you're popping out any value or any element, sorry, not value, any item from a stack, you need to check for the underflow condition. That is the first thing. And how do I check it? If top is -1, it is underflow, right? So let me write this with the existing example. The procedure is very simple. Check for underflow. That is stack condition. That is, you have to check for underflow or stack empty condition, because from an empty stack you cannot pop out any values. So how do I do that? Compare. So check if top is equal to -1, right? So what is top here? Top is 4, right? Because 0 to 5, top is pointing to this location. So top is 4. So I'll say -1 and 4 not equal. So no underflow condition. Now how will you pop out? When I say pop, see, when I will say push, you have to increment top and then insert the element. Here first you pop out and then decrement top. So I will have int element, one element Okay, or I can have item, whatever you want. I'll say ELE is equal to S of top. That is, what is S of top? Which is nothing but equal to S of, what was top? 4, right? The value of top is 4. So what is S of 4? ELE is equal to, what was S of 4 here? 120, correct? So it will have 120. You will print the element popped out is 120. After that, once I have popped out the element, what should I do? I should decrement, because this element will not exist now. I have to decrement top by 1. It should then point to the next element which will be popped out, right? So top minus minus. Top minus minus is nothing but top is equal to top minus 1. So here it will come, top will point here. Because once first check for underflow, then you have to see, you have to store the element at the top location. Only after that you decrement top by 1. Without storing, if you decrement, then you will not be able to get the element. So for that reason, decrement it, and then top minus minus is nothing but 3 minus 1, 4 minus 1, which is equal to 3. So top is equal to 3. Now top is equal to 3 in this iteration. Hopefully you have got this, right? I'll be doing till the underflow condition. Let me do it till the underflow condition so you will understand. But every time you run the program, you need not pop out the elements till underflow, or you need not push in the elements to till overflow. Like push and pop happens whenever the program requires. It is not compulsory that it should happen like first you put, yeah, to pop out at least one element should be there in the stack, and to push in at least one vacant space should be there in your stack to push in the element. Those are the only conditions. Otherwise push and pop, depending on your requirement, it varies when you do what operation. The next is, now if I want to do check for again underflow, check for underflow condition. So how do I check? If top equal to minus 1. So check if top is equal to minus 1. That is how, because when there are no elements in stack, then top would be minus 1. Otherwise, it will be pointing to some location if there are any elements. If only one element is there also, top would be 0, not minus 1. Okay. So if top is minus 1, check if top is minus 1. So what is, compare, what are the comparisons? And 3. What is the value of top here? After the first pop operation, the top is reduced to 3 because I popped out the element in the location 4. So I have reduced it, and it would be pointing to the element, that is the next element which has to be popped out, which is in the 3. So there is one vacant place. If I want, I can push in an element there. Again, the top value will be 4 once I push in. Since I haven't done any push operation, still it is vacant. So the top will be having 4. Now, sorry, 3. 1 and minus 1 and 3. So, not equal. What will I do? I have to first pop out the element ELE is equal to S of top. So, which is nothing but S of 3, right? S of top is nothing but S of 3. So, ELE is equal to, what is the element at that location? S of 3. So, it is 100. So, 100 would be stored in ELE. See, ELE again is a variable. Previous time it has taken 120. I would have printed the element popped out as 120. So I don't need it again. I rewrite on that only. Getting it? ELE is equal to 100. After that, what I should do? Once after popping out, I need to reduce or decrement top by 1 so that it will point to the next element which needs to be popped out, and there are two more spaces, that is the stack is not full. To begin with it was full, so I couldn't have pushed. Now I have two places wherein I can push in two elements. Getting it? Popping out. When I push in two elements again, when top goes up, that last element in would be the first element which will go, not the element in the top location now. So don't get confused. See here, now since I have not pushed in any elements, I have only popped out. The first element is popped out, second element is popped out. Now I have to decrement the size of decrement my top. So what will top be equal to? Top minus minus. So what will be my top equal to? Top will be is equal to 3 minus 1, which is equal to 2. Getting it? Now let me go up and take that out. So top would be pointing here. After that, what should I do? I will show you till the underflow condition. So next, again I want to delete, check for the underflow. Every time you want to use pop, you need to check for the underflow condition. Check for the underflow condition. So check if top is equal to minus 1. What is the value of top? Top is 2. So minus 1 and 2. So not equal. So what I should do? ELA is equal to yes of top, which is nothing but yes of 2. What is yes of 2 here? Yes of 2 is 99. So 99, then top minus 1, which is nothing but 2 minus 1, it is 1. So top is equal to 1. Let me go back and make that there. So top would be pointing to 1 here. Okay, hope I'm clear here. Then after that, suppose if I want to reduce or pop out one more element, again the procedure is you need to check for the underflow condition. How do I check it? Check if top is equal to minus 1. So what is top? Minus 1 and 1. Not equal. Not equal. So I have to first pop out the element. ELE is equal to, what is it? Yes of top. That is nothing but yes of, what is top now? 1. Okay. So ELE is equal to what was there in the location 1, the top pointing location is 78, right? So we'll go back. It becomes 78. And then what should I do? After that, I have to decrement top by 1. Don't forget this. Don't decrement and then write it into the element. First, it has to be popped out. That is, the element has to be stored. That is, the popped out element has to be stored in the ELE variable. And then you are decrementing top by 1. So, top is equal to top minus 1. You can use minus minus. Here it is coming as a single dash. That is why I am writing this. So, top is equal to what was top? 1 minus 1, which is 0. But still again 0 is valid, which means that there is one element in the list because array subscript starts from 0. Then I have to reduce this. This one will point to the 0th location. So, here there is still one element in the list. You can see that size is shrinking also. As and when I am popping out, it is going down. Right? Now again, check for the underflow condition. How do I do that? Check if top is equal to minus 1. Right? Then what are the comparisons? Minus 1 and 0 not equal. Minus 1, 0 not equal. So, I will say ELE is equal to yes of top, which is nothing but yes of 0. What is S of 0? Is equal to, what is S of 0 over here? It is 34. So, it will be 34 over here. And then top is equal to top minus 1. So, it is 0 minus 1, which is equal to minus 1. Correct? 0 minus 1 is nothing but minus 1. So, top is minus 1 now. Sorry, where did it go? After this, again we'll go back. Yes, that should also go, and then it will not point to any element because there are no elements in my stack. It becomes an empty stack and top becomes is equal to minus 1. And top would be minus 1 only in an empty stack. Now, if I try to again insert an element, delete an element. So, I should first procedure is check for the overflow, underflow condition. Check for underflow condition. How do I check that? Check if top is equal to minus 1. So, minus 1 and minus 1 equal print. What will you print? Stack empty underflow. So, this is my pop operation. Pop operation is nothing but first you have to check for the underflow condition, that is during underflow, that is if you are trying to delete or pop out an element from an empty stack. Since there are no elements, you cannot pop out. So if you are trying to pop an element from an empty stack, that gives rise to a stack underflow condition, that is empty stack, you cannot delete any element from that. And how do you check that? Top my is equal to -1, it will only have -1 when the stack is empty. So you go on comparing it with top. Top will be pointing to the element which was inserted last and which would be the first one to go out, last in first out. So if they are not equal, then you need to store it or pop it out into a variable and then decrement the value of top so that it will point to the next element which is in the line for going out. Getting it? Please, hopefully you have understood this condition or the procedure of deleting and what is stack underflow condition. Now we will start with the pop algorithm. So this is very important. Either they ask you push and pop or they ask you fuse. It's a commonly repeatedly asked question. Please make a note of the algorithm here. We'll be writing the algorithm first. Let us go through the statement of it. Before that, we'll see what do you mean by pop. So pop is a process of deleting one element or item. What is pop? It is the process of deleting one element or item from stack and is represented by an operation called the pop operation. Pop is nothing but deleting an element or an item from the stack. Here we'll have to check whether there are any elements for us to delete. Yeah, because if there are no elements, at least one element should be there in the stack to delete. If there are no elements in the stack, you will not be able to delete. And if there are elements, if there are no elements, it gives rise to the underflow condition, that is stack empty underflow condition. But if there are elements, then you will have to delete the topmost element from the stack. Please make a note of the statement. Hopefully you have gone through this algorithm for pop operation. So stack is an array that stores n elements. That is, the number of elements or the size of stack is n. That is, the maximum number of elements you can push in is n. The maximum number of elements you can pop out is also n. When the stack is full, you can pop out n elements and it becomes empty. Top is a pointer to the top element of the array. That is, top points to the last in element and the first out element. That is, you can delete and insert from only one end, that is the top end, and top is a pointer which points to the element which was last pushed in and which would be the first pushed out. This procedure, the procedure of deleting the topmost element from a stack, is called pop. Getting it? You have noted down it. So let me start with the algorithm. Please make a note of this. This is a commonly asked question in your exam. So algorithm for pop, what would be the first step? So what did we do first? We checked for the underflow condition. Yes. So what is underflow? Whenever you are doing pop, the first step is always to check for the underflow condition. What is underflow? That is, if you are trying to delete or pop operation on an empty stack, which means that there are no elements to delete. If you are trying to delete from an empty stack, it is stack empty underflow. We did that. I showed you how that underflow condition also arises. Otherwise, what we have to do, that also I showed you in the example. So, step 1, check for underflow. How do I check for underflow condition? So when there are no elements in my stack, then the value, the top would be -1, right? So if top is equal to -1, if it is true, then what I should do? I should print stack empty underflow, correct? Print. So I'll say stack empty underflow if the top is equal to -1. If it is -1, then it is underflow. After that, exit, then end if. So first, whenever I am doing this, the first step should be to check for the underflow condition. How do I check? Underflow is nothing but when you are trying to delete, pop an element from an empty stack. That is, there are no elements in my stack. At least one element should be there to pop, to use the pop operation. If top is equal to -1, then print stack empty underflow and you have to exit. If this is not true, that is, if top is not equal to -1, what will I do? Step 2, right? What should I do? I should return the top element of the stack, correct? First you have to take in the element and then decrement the pointer, not decrement and take in first. Return the top element and then you have to decrement the pointer. So I'll say return the top element. How do I do that? Item is equal to stack of top. There in the this thing I used s of top, right? Here also in the question, if you write yes is an array, then it will work like stack is of n elements. Instead of that I can give s. Here I had given stack in the question, so I will use stack only here. Stack of top. So item will have the RHS gets substituted into LHS, the stack of top, whatever is wherever the top is pointing to, that value gets, the value in that location gets substituted into item. Once it is done, what should I be doing? The next step is to decrement the pointer. Yes, once it is done, I should reduce it, right? Decrement the pointer. How do I do that? I will say top is equal to top minus 1 and then return item. Step 4. Return. So this completes my algorithm. First I need to check for the underflow condition. If top is equal to -1, it is an empty stack, then I cannot delete. If there are elements, that is empty stack is not true, that is underflow condition is not true, first I need to return the top element and then I need to decrement the pointer. That is the procedure. Please make a note of this. This would carry 5 marks for you. And if you understand this, it will be very easy for us to write the program. We will write a program also after this. We'll write a program, okay, to perform. See, when I have to do push, it is easy because pushing in, but pop, until you push in an element, you cannot delete. So we have to do push as well as pop. So I will do program to perform push, or I can say stack operations. Fine. A program to perform stack operations. Let me start the program. So please make a note, and this is also a lab program. Please make a note of it. We have done push algorithm, we have done pop algorithm. So it is easy to put it in a program. Hash include IO stream dot h hash include conio dot h hash include ctype dot h hash include process dot h. After that, hash define size, or I can let it be size only, size 5. So these are all my hash include statements. Let me start with the class. Class is a keyword to begin with. Class, to define a class, declare a class, I need to have the keyword class, which is in lowercase, okay, and let name of my class be stack. So in the private section, if I don't specify anything also, by default it is private, and private cannot be accessed outside the class. In private, what do I have? I'll have data members int yes of size top, and let me have element I. Okay, these are my data members which is declared in the private section of my class. And if I am using anything else, I will come back and declare it. To begin with, let me have these many elements, that is int s of size is 5. So the maximum element would be 5 top ele and I. See, when you declare, you will have maximum number of elements you would have declared, and you will ask the user how many elements you want to do, right? But you want to enter, but in a stack, once you declare the size, You don't have to ask the user how many elements you are going to push in or pop out. It happens like push in, pop out. When it reaches the maximum, it will give you an overflow condition. When there are no elements, it will give you the underflow condition. So you don't have, it as a fixed size. Like since I am having array based implementation, I have declared the size as 5. So 5 elements it will take. Getting it? You don't have to worry about, like, see, I don't put it in a for loop to enter the elements, right? So it is that way. The programming wise it is different. So int yes of size, top, ele and I, these are my elements. In the public section, let me have constructor, then void push int void pop and void print. Okay, let me complete my class here. So how many functions? I have 3 member functions and 1 constructor, wherein I would be giving the initial value of top to -1 to begin with. When there are no elements in the stack, the empty stack, let me have the top is equal to -1. Okay, so my class is complete. I have terminated my class here with a semicolon. So let me define all the functions which are declared inside the class, outside the class. So stack, scope resolution operator, I will say is equal to -1. So this is the initial value of it. Fine. After that, let me write the push function. So how do I write it? Return type, name of the class to which it belongs to, scope resolution operator, name of the function. So what is item? It's the formal parameter. The parameter in the function header is called the formal parameter, right? So what is the first step when I do push operation? Let me write a comment here. Check for overflow condition. Comments are what? Non-executable lines of code, right? These codes do not get executed. Non-executable lines of code which increases the understandability or the readability of your source code. What I am writing is the source code. So anybody else looks also, they will be able to understand why or what each block does or what you are looking for. So comments, when you write it in, it makes the program more meaningful. So wherever you can, please do write comments. Comments are non-executable lines of code. There are 2 types of comments, single line comments and multiple line comments. Let me write a single line comment here. When I have to push, what I have to do? Check for the overflow condition. That is whether there is any place in the stack or not. Check for overflow condition. So, okay, since it's a comment, I don't have to terminate because it does not get executed. How do I check it? Check for the overflow. How do I do it? If top is equal to size -1, that is 0 to size -1 are the elements of my stack. So, if top is equal to size -1, what should I be doing? I should write cout stack full overflow. Okay, I'll be writing this. After that, then return. This is my end of my if. So what did I say? I have to check for overflow condition when I am doing a push. If top is equal to size minus 1, size I have declared S of size, right? Size was 5. Then 0 to 4 would be the element. When you are pointing to the, if top is pointing to the last element, still there are no place left for pushing in the element. You need to specify stack, full, overflow and return. Otherwise, if it is not true, then what will I do? If it is not true, else let me write what I have to do. First, I have to increment top, right? Because top would be pointing to the last element pushed in. So, I have to make it point to a vacant place. So, top plus plus. First increment top and then push the element or push the item in that location. So S of top is equal to item. Where do I get the item? I am getting it from main. That is the calling function. I would be calling this from main and from there I will be passing the argument as a I am passing item as an argument here. That is why I am not having any cin statements here because I am not taking it in the function. I am passing it from main. After that, what should I do? That's it, right? So, or I can say C out. I would say element item pushed in successfully. So that the user will know, okay, whatever item, when you don't write without codes, if you write this, whatever is the value in that variable would be written. Getting it? Then I will end my else here. Afterwards, I have nothing else to do. I will end my stack push function here. So how many brackets you need to check? My opening bracket for push and closing for push is here. Okay. If I start it here and end it here, else I start here and end it here. Okay. So hopefully you have understood the push function. That is item. Then check for the overflow condition. If top is equal to size minus 1, the out stack overflow return. Else top, you have to increment top. S of top is equal to item. Where did I get the item? I would be passing it as an argument during the function call from the calling function. So from the calling function, whatever argument is passed is called the actual parameter. The function header, it is called the formal parameter. So element item pushed in successfully. If I push in, I will be displaying this message to the user. So this completes my push. Let me write my pop. Return type of that, name of the class to which it belongs to, and there are no arguments, so it is blank. So what is the condition I need to check for? I need to check for the underflow condition. Again, this is a comment. Check for the underflow condition. I am writing a single line comment here. How do I check for the underflow condition? I have to say if top is double equal to minus 1. When will top be minus 1? when there are no elements in the stack. See out stack empty underflow. So stack empty underflow. Once I check that if the stack is not empty, what I should do? It goes to the else, right? If the stack is not empty, then first I need to take out the element. So what was the variable I declared here for storing in the element? It is ELE. So I will say ELE is equal to yes of top. Correct? Yes of top. Then what will I do? Yes of top. Then I will decrement it. Before that, let me print that element also. Cout element ELE popped out from stack successfully. Okay, this is done. After that, top minus minus. You have to reduce top by 1 so that it will point to the next one. So this is my else. So what did I do in else? If I check for the underflow condition, if top is equal to -1 stack empty underflow, else what will I do? ELE, that is the element which I have declared in the private section of the class, because the pop function is also of the class tag. It can access the private data of the class. ELA is equal to yes of top. Then cout element would be printed as it is. ELE, the value of that element, popped out, that is value, the whatever is the element present at the top location, popped out from stack successfully endl. After that I have to reduce top by 1. Okay, then return, I close my else here and then I close my function here. Whenever you are writing a program, please check for number of open brackets to be equal to the number of close brackets. Otherwise, one bracket missing or put in an not a proper place gives you a lot of errors, and debugging also would become very difficult. So I have opened if here, I have closed it here, else here and then my function. After that I need to write my print function. So how do I write it? The return type of the function, name of the class to which belongs to, scope resolution operator, print. Okay, no arguments to it. That is why it will be as it is. What is this doing? Display the contents of stack. Display the stack contents. Okay, it will display me the stack contents. So I had declared one more variable I. Have I declared I there on the top? I think yes. Yes, I have declared I. So it should not give me any error. What will I do? For I is equal to 0, because the first element subscript value is 0, or the index value of the first element or the location value of the first element is 0, then I less than or equal to top, I plus plus. Okay, so I will say Cout yes of I. Till the top element it will print, and then I will give a tab space between the elements, close my for. So before that, let me say what it is to the user also, right? Because to display the Cout stack contents, so this would be displayed, and my for here, and let me end my print function here. So we are done with push, pop and print. Now I have to write my main, right? Void main. So let me say clear screen. Then how many variables I need? Let me say int item, because I'm going to take in that and I need to pass it to the push function. And let me have one more integer value, choice. This is for my menu, the user's choice. So let it be there. After that, char ch is equal to y. Okay, while ch is double equal to y. Hopefully you know the difference between single and double equal to. In single equal to, it's an assignment operator. I'm assigning the value of it. Here I'm checking, it's a relational operator. Double equal to is a relational operator which checks whether the LHS is equal to the RHS or not. Let me start my while here. What will I say? Cout and one push. Cout and two pop. So Cout and three print. Cout for exit. Okay. So these are the menu options. Before that, in main only, let me create an object. Without creating an object, I cannot call. How do I create an object? The class name, stack and object. So stack name and object, when I create this, it would be assigned to -1 top. After that, I have a while loop. Ch is equal to y. First time it will be true because I have given an initial value. As soon as it comes here, it will print this menu to the user. That is, if you enter 1, you will go to push, 2 is pop, 3 is print, that is printing the elements of the stack, and 4 is exit. After that, what I have to do? See out, enter your, I have to ask the user to enter the choice, right? And I have a variable, integer variable choice declared, so I will take it in that. The user can enter 1, 2, 3, 4, or he can enter any other number. What is the case I should use? Multiple this thing, I can use a switch case. And this is only integer, so switch case works well with the integer or one single alphabet, right? You cannot use float values in the case. So switch, and what is this thing? This one, because choice is a variable which will take multiple values, correct values, like 1, 2, 3, 4, 4 values. Anything you enter are correct values for choice. Depending on your choice, it will do accordingly. So switch case is a keyword. The first value of choice is 1. If I do enter 1, I have to do the push operation. So for push operation, first you need to ask the user to enter the item, then element to be pushed in, take in the item, and then you need to call the function and pass the item as a argument to the function, right? So how do I do that? See out, enter the element to be pushed in. So you're asking the user to enter the element. See in, what was the variable I declared? Item. So I will be taking it in that, and now I should call the function. I have already created an object, sobj dot push, and item is the actual argument which I'm going to pass, and then break. This is the case 1. Enter the element to be pushed in, see in item, then call the function and break. Case 2. What will case 2? Case 2 is to pop the element, right? I have used the pop, so I don't have to take in anything. So yes, so bj dot pop. I have to call, this is the function call, and then break. Case 3. What is the case 3? I have to call the print function. Dot, because I need to display, right? Then, okay. After that, case 4. What is the case 4? Exit. Dot, so exit, it will exit the application itself. Now I have to write the default. If the user enters anything apart from 1, 2, 3, 4, I need to write default, does not have case, only default, see out, invalid choice, okay, and end of my switch. So invalid choice, case 1, enter the element to be pushed in, see in item, and then I'm calling the push function and passing the item as an argument, and break. I'm calling otherwise pop function, then I'm calling the print, I'm calling the exit, and then invalid choice. This is the end of switch, not the end of while. After that, I have to ask the user, do you want to continue, right? It's not like I will do only one operation. If I want to do multiple operation, I should give that choice to the user. So see out. Do you want to continue? Yes slash no. Question mark. C in CH. I need to take it in CH. CH is equal to lower CH. And then I end my while. So after that, what happens? See here, please pay attention. I have the object creation, then the variable with an initial value, two integer variables, item and choice. Then while starts with the menu. This menu would be displayed every time the while loop would be run, and then the choice of the user would be taken. Depending on the choice, that particular function would be called, and if you give an invalid choice, it will give you, if you write anything apart from 1 2 3 4, it will give you an invalid choice message. After that, if you want to continue, yes or no, you want to again do one more operation, yes or no, then I am taking in it in ch, and then I am converting it to lowercase, because while ch is equal to lowercase y I am checking here, but as a user, uppercase or lowercase means same to me. This is the end of my while. I close my switch, I closed my while. Let me close my main also. So this completes my program. So hopefully you have understood this. Again, I will explain this to you tomorrow when I execute it on the system. Fine. Now please make a note of the homework question. Only one question. Write an algorithm to perform pop. Okay, please make a note of this. This program, again I will explain it to you and I will show you the execution in tomorrow's class. Hopefully you have understood pop operation. Yeah, if you have not understood anyway, you are welcome to write it in the chat box. I will try to clear it, and if there are more, then I can do it in the on the next day also. So take care, stay safe. See you tomorrow. Bye bye.